My name is Devendra Tiwari. I am a program manager in the Azure Security Engineering team. In the next 60 plus minutes, what we are going to do is we are going to look into the different capabilities we have currently offered as part of the Azure data protection strategy. At the same time, what's coming in the next 3 to 6 months to help you protect your data across different workloads. I have with me my colleague Thomas, who is going to speak on some of the data protection capabilities from the access control perspective. So we can start. I see few seats still to be filled up. So we can either maybe wait 30 seconds. I see some folks in the still walking. So I can understand it's been a long day and this is the last session of the day. So we are not going to hold you long for between your dinner and other plans. So we'll try to keep it exciting and at the same time enlightening. And we'll try to wrap it as soon as we can. Should we start? Okay. So I got a go green from the back. So once again for folks who have just got in, my name is Devendra Tiwari. I'm a program manager in the Azure Security Engineering. We drive the security capabilities across Azure to help protect our Azure infrastructure, which makes the platform and at the same time helps keep our customer data safeguarded all the time across different scenarios, different workloads. I have with me Thomas, who is a program manager in the same team. Thomas, you want to introduce yourself?
Yeah, so I work in the Azure Security Services team, focused on access control technologies, authentication, authorization, just-in-time elevation. So the latter half of the talk, I'm going to touch on access control tech and specifically how that intersects with data protection, key management, and elevated access scenarios.
Thanks, Thomas. So as I was saying earlier, in the next 60 minutes, we are going to look into the data protection offerings we have currently, and at the same time, what's coming in the next 3 to 6 months to help our customers safeguard the data. So with that, welcome to the Enabling Data Protection in Microsoft Azure talk. Let's quickly go over what we are going to cover. Do I need to point the clicker in a particular direction? Okay. So in this session, what are we going to cover? In the next 60 minutes, we are going to cover how Microsoft Azure helps you protect your data across the different workloads, across the different containers, be it storage, be it SQL Server, be it HD Insight, be it Azure Backup Services. So we'll go through the different workloads, different scenarios, and look at what are the different capabilities we have currently in the offering, and at the same time, as I was saying earlier, what's coming up to help safeguard the data. Now, we'll also look at what controls you can bring in to customize the encryption technologies, and at the same time, how you can integrate those controls with the recently announced Azure Key Vault, which is our key management offering, to help control and protect your data and at the same time the keys and the secrets. We'll touch into the data retention and the data deletion or the data destruction technology. And at the same time, as Thomas was saying, we'll look into the access control protections we have as part of the platform. And at the same time, what are the access control offerings we have for our customers. Now, what we are not going to cover in this talk is the first one, the Data Protection Manager. The Data Protection Manager is a product offering by Microsoft, and we are not going to cover that technology in this talk. We are not going to look into the compliance controls and the certifications. We are not going to look into the privacy aspects or the data classification aspects of safeguarding the data or the data protections. And at the same time, even though the talk is about kind of look into the encryption offerings or the encryption technologies, we are not going to go into the crypto 101. Now, everyone knows that the cybersecurity concerns, they have been persisting, and at the same time, the security threat landscape has been changing. The bad guys are getting better, their motives and the act have been increasing. In fact, if you look at the recent the data breach report, 2014 has been the largest data breaches, kind of the year where the largest data breaches have been reported. So yes, the cyber crime has been increasing. As I said, the motives, whether it's a small actor or whether it's a state-sponsored activity, the threats and the landscape is continuously changing and evolving. So with that, also means that we have to continuously evolve our technology to help safeguard the data and to help protect the customer sensitive or the high business information. Now, we have set of security controls which are implemented as part of the platform, which makes the Azure platform a trusted platform. And at the same time, we also offer a set of controls to our customer to help customize their environment based on their application needs and the workload needs. Now, how do we do that? So we have our Microsoft Cloud Security Strategy that basically helps us to protect, detect, and respond based on the circumstances, based on the situations, and based on the needs. Now, these are the list of security controls which are deployed or implemented as part of the platform. Now, we call them as the built-in controls, which makes the platform or which makes the platform trustworthy. Now, we are not going to go through the entire list of these platforms, or we are not going to focus on each and every control, security controls listed here on the slide. What we are going to do in the next 60 minutes is, of course, based on the title of the talk, we are going to focus on the data protection, the data encryption, and key management aspects. We are going to deep dive into the scenarios and the offerings, as we were saying earlier. Thomas is going to cover from an access control perspective, what are the access control framework we have, what are the access control offerings we have as part of the framework, and at the same time focus on some of the other capabilities like just-in-time, JIT, or the just-enough access capabilities. We'll briefly touch into the data isolation, what capabilities or how do we support our multi-tenancy to ensure that the data is segregated across tenants. And then we'll look into some aspects of logging and monitoring. So data protection at a high level, if you look at some of the principles we apply across data protection, we look at from the data isolation perspective, is the data isolated across tenants, given that it's a Azure is a multi-tenancy model? What are the different framework or what are the different controls we have to ensure that isolation, logical isolation, at the same time physical isolation? Then when you look at the data protection from a in-transit perspective versus at-rest perspective, then we are talking about what are the key capabilities or what are the different technologies we offer to ensure that the data stays protected in transit, the data stays protected at rest, and not only the data stays protected, but at the same time the data is within your control. The data is the keys which protects, or the key management scheme which you opt in is under your control, and you have, you are the custodian of the keys, the data, the access control principles and all that. So from that perspective, we'll cover the at-rest protection and the in-transit protection. And then of course, we'll look into the encryption technologies and the encryption offerings from the solutions perspective. So those are some of the key, you can say, the areas or the topics we would like to cover in the coming slides. So when we talk about the data encryption options, how do we protect the channels? What are the different scenarios we consider, or what are the different capabilities we allow to the customers? For some reason, is something wrong with the Flickr? The tech guys? Oh, I need to press it hard. So sorry, it's been at the end of the day. So, so when we talk about the in-transit, scenarios, so we are looking at the in-transit between the user and the service. So what are the options the user have when the user is communicating with the service, the Azure service, or the applications which are deployed in Azure? Then what are the options available for the user to protect that channel or to secure that channel? So when you come in through the portal, you log into the portal, the communication between you and the portal is secured through HTTPS. Of course, the strong ciphers are used, which ensure that we adhere to the compliance mandate. The FIPS 140-2 support is enabled. Now, when we are talking about the service-to-service communication, or when the data is in transit between data centers, so what happens? So there are two aspects to this. One aspect is you could have a data communication between services within the data center, or you could have a data communication across data centers. So in all those scenarios, the data always stays encrypted because the communication within or the communication across the data centers are always encrypted. So that's the assurance Azure offers. So that takes care of the data in transit between the data centers. Now, end-to-end encryption of communication between the users. Now, what happens when you are, let's say, kind of a similar scenario which we were looking at earlier? What happens when you are trying to communicate, let's say, through storage APIs? You want to upload a storage blob, or you want to, let's say, write to a storage table. So in that case, how is that communication secured? What kind of options you have? Now, storage APIs, they support HTTPS. So yes, you can opt into, or you can choose HTTPS to secure that communication. Now, you can also use HTTP, but that's not a recommended practice from a security perspective. So we always recommend that, yes, whenever you're trying to directly communicate with the storage service, either for kind of blob or for table related operations, then we always recommend that you use the HTTPS operation. At the same time, if you could have .NET like applications where you want to really communicate with the Azure services. In that case, we definitely recommend that you encrypt the traffic between your the web client and the server by implementing your secure channel, which is the TLS or the SSL. Now, when we look at the data at rest options, so there are a lot of details on this slide, so we'll go one by one. And this is the slide where we want to spend some time. Now, when we talk about the data at rest scenarios from a encryption perspective, from the protection perspective, the first scenario we are looking into is your virtual machines or the VMs. Now, it could be your Windows VM or it could be your Linux VM, where you want to provision your Windows apps or Linux-based app on your VMs, the IaaS-based VMs. Now, what are the protection capabilities or what are the encryption capabilities we offer there? So we'll look into that. Now, the second thing is the SQL Server scenario, where you could have your data residing in the SQL Server as a container, or you could have your data stored in SQL Server as a container. So we'll look into SQL Server from the IaaS perspective and SQL Server from the PaaS perspective. What are the encryption offerings or the protection offerings there? As from a storage perspective, Azure Storage, when we talk about blobs, table, cubes, then what level of protection available to you to protect the data at rest? So we'll talk about that. Now, HD Insight. HD Insight is an interesting scenario. Now, you may be wondering, like, if I am a consumer of an HD Insight service, then do I really need to care about the data encryption? Do I really need to care about encrypting my data or protecting my data at rest? Now, the HD Insight service could be leveraging the Azure storage as the underlying container, or it could be using the SQL Azure database or SQL PaaS as the underlying container. Now, in that case, you could think that, okay, well, then if the containers offer the encryption guarantees, or if the container can encrypt the data for me, then I, as the HD Insight service or consumer of that service, may not need to take any action. Only thing I need to worry about is to ensure that, yes, my service has proper access to the container to be able to read the encrypted data or to be able to get to the encrypted data. So HD Insight is kind of interesting from that side. Now, Azure Backup Service. it's another interesting scenario. And it's an interesting scenario because when your data is encrypted in a VHD inside SQL Server or in another container, and when you're trying to perform backup using the Azure backup service, then you may be able to get the backup of the encrypted content, and you're pushing that content into a secure vault. But then what happens when you're trying to restore the content? Because the content is encrypted, the restore operation would fail if you don't have those the keys to the kingdom. The keys to the kingdom, the encryption keys which have originally encrypted your contents. So Azure backup service is another interesting scenario when we talk about encryption across these different workloads. So we are talking about the VMs, Windows and Linux. We are talking about SQL as the container, storage, HD inside, backup. Now there could be other scenarios which could be interesting. So we would like to definitely hear from you guys and see if what are the offerings we can either currently have or we need to work on. Now on the right side of the screen, you will see that across each of these workloads or across each of these containers, we are talking about data and we are talking about the keys which encrypt and protect those data. Now, where do those keys end up? And who has control over those keys? Who has access to those keys? And who ensure that any access performed against those keys are audited and logged? And then you have visibility into that. So all of that across all of these scenarios basically lands into or results into the keys residing in the Azure Key Vault as the key management scheme. So Key Vault basically provides you kind of a container to securely protect your keys and secret. But at the same time, it also ensures that the customer or you as a user have full control over the access. It also ensures that yes, the access is not granted by default, to users unless the user has explicitly granted that. And we'll look into some of the scenarios and kind of deep dive into it. So with that, we are introducing a solution, the Azure Disk Encryption. Now, this is the solution which will allow you to encrypt your VHDs at rest for IaaS, Windows and Linux, which means that you as a customer, when you come to Azure, you provision a VM, you request to provision a VM for your Windows or Linux, and because of compliance, security and other commitments and mandates, you want to encrypt those VMs or you want to encrypt those VHDs. This is the solution or this is the offering which will help you with that. And this offering is integrated or will be integrated end-to-end into the Azure experience or as part of the platform, where we'll ensure that either you come through the portal or you come through the API or you come through the PowerShell commandlet. You will have an option to turn on encryption for your OS disk or the boot volumes. You have an option to turn on encryption for your data disk or for all the data volumes across Linux and Windows. So that's the solution we are going to demonstrate. Sure, go ahead.
Are you currently encrypting the images for Azure Site Recovery?
So that's a good question. Would you mind holding on to that question till we get to the demo and the scenario? Thanks. So speaking of the scenarios from the Azure Disk Encryption perspective, now what scenarios it's going to cover? We talked about the OS disk and the data disk, and on the next slide we'll look into what are the scenarios we cover. But at the same time, when we talk about the value propositions, we talked about helping meeting the security, compliance and the privacy commitments. But at the same time, some of the other value proposition is your data is always secured at rest. Your data is always encrypted at rest when the data is in the storage. Now, imagine how do you get access to the storage? You get access to the storage through the storage account, which is basically a SaaS key. Now, imagine your storage account is compromised. Typically, application developers, they will hardwire or hardcode their storage account or keys inside their configurations. Now imagine if that has happened and your storage account keys are compromised. So in that case, what's going to happen is some bad guy has gotten hold of your storage account keys and is able to now grab your VHDs. So today, because the VHDs are not encrypted, that's a bad sign. But now, once we have this Azure disk encryption solution and you have opted in to turn it on, your disk will be encrypted. So even if your storage account is compromised, let's say, we definitely don't want the account to be compromised. But just in case, if it gets compromised and somebody is able to steal your disk, then the theft of that image is meaningless because the keys to the kingdom are residing somewhere else. And we'll look into what exactly that means. Now, you have an option to boot the VMs under the policies and the keys which are controlled by your CISOs or by your CSOs or by your corporate policies. And then, of course, we talked about auditing the usage, who has access to the keys of the kingdom, and where the access is being performed from. And some of the threats we talked about, yes, loss of disk, either from a compromised storage account or otherwise. So some of those threats, they get addressed to help meet your security and compliance commitments. So these are the scenarios, if this clickers cooperate. So these are the scenarios we are introducing to help you protect your data at rest, across these 3 different scenarios. Now what these 3 different scenarios mean is the first one. So so this works. So the first one is new VMs from customer encrypted VHDs. What does that mean? Imagine you are using your on-premise. You have your VHDs encrypted today for your Windows or for Linux. And you want to bring those encrypted VHDs into Azure as part of your application migration. So the first scenario would basically help you with that. The customer encrypted VHDs with the customer encrypted keys, you can bring them into Azure, and then Azure will provision a VM, and the VM will be protected using the technology we'll talk about as part of the Azure disk encryption offering. The second scenario is you come to Azure and you pick an image from the gallery, a Windows image or the Linux image, and you want to turn on encryption, boot volume or data volume as part of the VM provisioning. You will be able to do that. That's the second scenario. The third scenario is you already have virtual machines or VMs running in Azure. And now, once the solution is available, you want to turn on encryption to meet your compliance commitments. You will be able to do that. So those are the 3 scenarios we are looking into as part of the Azure disk encryption offering to help you safeguard your data at rest. Now, so we talked about some of the protection elements from an access control perspective. We are talking about, yes, the keys to the kingdoms, they belong to you. They are under your custody. You control who has access to them. You control who those keys should be shared with, what application those keys should be shared with. Of course, you have the ability to turn on monitoring and logging to gain insight into the VM state. From a data security and availability perspective, so with encryption comes certain cost, as you know. Now, once your disks are encrypted and they are staying encrypted, then yes, of course, you have to ensure that you're not losing the keys. So that's where the platform will help, making sure that yes, you have your the keys inside your key vault in your subscription. That's one thing. And at the same time, if you have Azure backup services, we talked about that. If you have Azure backup services, you will have the responsibility to ensure that not only you're backing up the encrypted VHDs, but you're also kind of backing up the the keys. And the Azure backup services will be tuned to support the Azure disk encryption scenario. So the data is stored encrypted inside your customer storage as the encrypted VHDs. In the key vaults, the keys will be inside your key vault subscription or inside your key vault container. And at the same time, not related to the encryption capability, but Azure today have that replication where the storage gets geo-replicated based on the region. So that will basically guarantee the data security and the data availability for your VHDs. Now let's take a look at from a flow perspective. So far we have talked about, okay, these are the scenarios where you have your VHDs encrypted on-premise, you want to bring them to Azure. So far so good. But how does that flow look like? What action the user or as a user I need to take versus what actions Azure as a platform will be taking to provision those VMs, So from a flow perspective, we'll look at what does that flow look like. So you have a customer or you are a customer who have encrypted disk on premise, right? Now you upload those encrypted disk into Azure using the Azure copy operation or the the other supported operations. You upload that disk, so of course the disk will stay encrypted in Azure. Now the second step is you have encrypted those VHDs with certain key material on your on-premise. So what you are doing is you have uploaded those key material. In this case, for Windows, it's the BitLocker encryption keys. For Linux, it's the Linux passphrases. So you upload that inside your key vault in your subscription. Now, so far, what you have done is you have just done the upload operation without granting anybody any access or without, granting any access to the Azure platform. Now, as a third step, what you do is you come to either the portal or through the API and you say, like, hey, I want to encrypt my VHDs, or I want Azure to provision a VM for this from this encrypted disk. And what you're doing as part of that configuration opt-in is you're pointing Azure to your storage, read the encrypted VHDs from the storage, and read the keys from this key vault and provision an encrypted VM for me. So the Azure Service Management will basically look at your opt-in, look at the configuration you are bringing in, and then will help provision a encrypted VM for your scenario. So now, which means that your on-premise encrypted VM is now migrated into Azure and is provisioned into Azure as an encrypted VM with the encrypted disk, depending on whether you are bringing in the OS encrypted disk versus the data encrypted disk. So that's how the flow looks like. And at the same time, not only the VM is encrypted, but the VHDs are protected inside your Azure storage. And we talked about the keys inside your key vault. So that's how the flow looks like for the encrypted VHD scenario. Now, what does the flow look like for a new VM or a running VM scenario? So in case of a new VM or a running VM scenario, you're not performing any kind of encryption operation on the on-premise. You're coming to Azure and you're opting into, okay, give me a VM and protect that VM or encrypt that VM, So with that contract, Azure will perform the same operation as a platform, and then will, now in this case, I need to call out one thing is because you have just come in and you want to, turn on encryption on a running VM or for a new VM. What's happening is you're not bringing any keys from your side. You're asking the platform to generate the keys, but at the same time, the platform is ensuring that the keys, they go inside your key vault. Now, how does the platform know that the key needs to go into your key vault? Now, when you bring in your configuration, you need to tell the platform that, yes, this is my key vault container, and here I want you to, push the BitLocker encryption keys or the Linux passphrases. And that's where, the keys are protected and the keys are controlled, including the access. So that's how the scenario looks like from the running VM or the encrypted VM perspective. Now, few more details we want to share. Now, we talked about the Azure disk encryption for Windows and Linux. For Windows, we are using the BitLocker as the underlying technology, which will encrypt your OS volume, the boot volume, and the data volume. So as the BitLocker, if you remember, the BitLocker solution is there as part of the OS platform for many releases now, and it's a proven technology. It's a drive encryption capability or technology introduced by Microsoft a long time back. So we are using that proven technology. For Linux, depending on the distros, depending on the SKUs or the flavor of the Linux, whether it's a CentOS versus SUSE versus Ubuntu, we will be using the DMCrypt as the underlying encryption solution for the Linux. Now, few things from the key management perspective, because whenever we talked about encryption, we said that yes, the keys are very important. How the keys are protected, who have access to the keys, and how is the access controlled by the platform versus by the user. So from the disk encryption solution perspective, we are saying that the keys, the BitLocker encryption keys and the Linux passphrases, they are stored, protected in the customer control in your key vault. So that's the first thing. Then the customer, you as a customer, you grant explicit access to the platform to perform operation like provisioning a VM versus enabling BitLocker operation, BitLocker encryption versus Linux DMCrypt encryption on the OS volume or the data volume, right? So depending on the operation you are performing, you grant explicit access, read versus write, to your key vault container to the platform. Azure do not have any default access to your key vault container. If you have not granted that access for provisioning the encrypted VHD's VM versus new VM versus running VM, then Azure cannot perform that operation. So you will have to explicitly grant that access to perform that operation. Now, kind of a high level schema, you can say, or a structure on how the keys and the secrets are going to stored inside your key vault. So key vault, there is a key vault talk tomorrow. We have Sumedh here sitting in the front row at 9 a.m. If you have interest, or if you want to learn more about key vault, what the technology is, what the offerings are, what the scheme supported, then I definitely encourage to attend Sumedh's talk tomorrow at 9 a.m. But at a high level, key vault, we talked about key vault as kind of a container for your secrets and keys. From the Azure disk encryption perspective, we are using key vault to store the BitLocker encryption keys and the passphrases as secrets, and we are using the key encryption key to protect the BitLocker encryption keys or your passphrases. So which means that on this side, when we talked about, this is always protected by the key encryption key. Now, the key encryption key could be you are bringing the key encryption key of your choice, or you are asking the platform to generate the key encryption key. But in either of those scenarios, the keys, they always stays protected inside key vault inside your container. So that's the high level overview about, including the workflow about the Azure disk encryption offering, the solution, the scenarios we are addressing to help safeguard your data, and then its integration with Key Vault or the Azure Key Management Service. Now that brings us to the demo. Okay, so Thomas just reminded me that I have 10 more minutes, so I need to speed up. So this is your view into the Azure portal. Now, what you're seeing here is you have a running VM, and on that running VM you have the OS disk and the data disk. Now, what we are going to do is we are going to simulate a script for the purpose of time or the shortness of time. We won't be able to run the script, but we'll show you what does that the script, which is basically a PowerShell commandlet, what does that look like, what parameter it takes, and how does it help you to BitLocker protect your OS and the data disk. So this is the PowerShell commandlet enable BitLocker. Now this commandlet takes a few parameters. It takes the VM name. It takes the key vault URI, where it will, because it's a running VM scenario, the platform is going to generate the BitLocker keys. Now in this case, the VM is a Windows VM, and through this PowerShell commandlet, I'm requesting to encrypt my OS volume and the data volume, or the OS disk and the data disk, and the keys will end up into this key vault URI. So I run this script, and then I wait for some time, and then I log into that VM. Now ultimately what's going to happen is, when you are inside the Azure portal, you don't need to do these steps, meaning you come to the portal and you opt into the encryption, the Azure disk encryption for the OS disk and the data disk, and then the platform will basically take those steps to encrypt it on a running VM. Now eventually what happens is, once that operation is completed, then what you get is your OS disk, which is the C volume in this case, and the data disk, which is the F volume in this case, is encrypted. And as you can see here, you have the locks appearing on this the VMs or this disk, ensuring that yes, it is BitLocker protected, or the volume is now encrypted using the BitLocker encryption technology. So that's how the ultimate result is. And when you run the, let's say, the status, you will see that from the status perspective, you will see that yes, the encryption is turned on, protection is turned on, protection is turned on your volumes, the OS volume and the data volumes. Now we talked about one scenario, so let me go back to the portal. So in the portal, we talked about the scenario where I have the running VM, you want to turn on the encryption. So you will have an option here to turn on the encryption and then provide a pointer to the key vault URI. And you won't have the need to, once you have opted into that, then the platform will turn on encryption, and then your VMs are protected at rest. Now you don't need to kind of log into the VMs, as I said, to look at some of the things. Now one of the things we talked about earlier was, if I am looking at my data disk here, then this data disk is stored in this storage location. Now in order to get access to that storage location, I need the SAS keys, or the storage account keys. Now we talked about a scenario where, let's say, your storage account keys are compromised for some reason, and somebody has got hold of this encrypted VHDs, the data disk or the OSDs. Now what does that kind of attack look like? So the attack is going to look like, where I am able to get, as a bad guy, because I have access to your storage account keys, I can go to this storage where your data disks are stored. I can copy those disks to my local machine, local system, or location of my choice, and then I can party on with those disks. But in this case, we talked about the offline attack scenario, where because the disks are encrypted and the keys are persisted inside, or the keys are protected inside key vault, that attack is not possible. So I simulated that attack, and I've copied the disk on this machine from this location. So if you look here, this is my AD VM Ignite disk. I have copied it as part of that operation. Now if I try to mount that disk, I cannot. So even though my storage account is compromised for some reasons, and I gotten hold of the encrypted VHDs or the disk, I cannot mount those disks, because the BitLocker encryption keys or the BitLocker encryption solution is protecting me from that attack. That's an offline attack. So that's the value proposition we talked about, where loss of storage account or loss of disk. Can you go back to 5? Now, this is the key vault scheme. If we look into how does those keys and the secrets looks into key vault, so this is how it's going to look like. If I want to go back again, so this is how it's going to look like, where you have your key vault name or your container. This is basically the URI you're pointing to, where your BitLocker encryption keys are going to be stored. And now, of course, this is going to be all cryptic and all gibberish. It's not going to make any sense. But this is how, when you query the key vault through the get Azure key vault secret with the dash vault name. Now, this is the vault where your keys to the kingdom will reside and will be protected, and it will be under your control. So that is all about the Azure disk encryption offering. Now, last week at Build, we also announced the storage client-side encryption. Now, what is the storage client-side encryption? So, imagine you have a .NET application and you want to encrypt sensitive information, passwords, secrets, or blobs, tables as part of your .NET application, and you want to push that information encrypted into Azure storage. So this is where the storage client-side encryption capability will help you. It will ensure that, yes, the keys are under your control, because as part of your application you are opting into the encryption scheme. As part of the application you are defining the strength of your keys and all that stuff. And at the same time, as part of your application, you are also defining where does those keys ultimately are persisted, whether it's Azure Key Vault versus the key management scheme of your choice. So that's the storage client-side encryption. It's in preview, and feel free to play with it. It allows for encrypting blob, tables, and the queue data. We talked about you can bring in the encryption scheme of your choice. Now, it provides you most controls, because you are now controlling the scheme, the encryption scheme, the key management scheme as part of your application. And at the same time, it also assures you that, yes, your data is encrypted at client and on the client side, and then it's pushed encrypted in Azure. Of course, the data will stay encrypted in Azure, because if you have not shared those keys with any of the application or with Azure, then the data will always stay encrypted in Azure, meaning that even the storage service cannot either get access to the data or see the data in clear.
What other key management systems are you referring to?
So if you look at this point, we are talking about the integration with Key Vault. So yes, you have an option to, as part of the Azure offering, to integrate into Key Vault. But if you are not using that as a scheme, then as inside your application, you can choose your key scheme as part of your application. I have a code sample here snippet, but there is a reference at the end of the slide deck which has more details around the Azure client-side encryption, and at the same time, as part of your application onboarding, what encryption scheme and all that you can use to encrypt your blob, table, or queue. Now, the third thing as part of the encryption thing, so we talked about the Azure disk encryption, we talked about the storage client-side encryption, the storage cloud integrated encryption, using the Store Simple as the solution. So if you have, or if you are using Store Simple currently on your on-premises for your backup data or any archival data, then Store Simple allows you to encrypt the data and bring that data encrypted into Azure as part of that cloud integrated storage. So which means that, yes, your data always stays encrypted in transit and at rest from your on-premise to Azure. So that's another offering we have as part of the storage encryption scheme. Now, moving on to the SQL Server as the container or the SQL Server as the store. Now, from the SQL Server perspective, we are talking about some of the options like the transparent data encryption (TD). TD has been there in SQL Server box product for a while now. I believe it was introduced in 2008. It's been there since then in the enterprise SKUs. The cell level encryption has been there, where at the app layer, inside SQL Server you can use some of the built-in encryption option to turn on cell level encryption. SQL Server encrypted backup, where you have an option to when you are taking the backup, you have an option to opt into encryption. So let's say for some reason your transparent data encryption is not turned on, your backups can still be encrypted using the encrypted backup, and your data will stay protected at rest. Always encrypted. There will be an option where you can choose during the design time to opt into a particular column or a particular table to encrypt your data, and to encrypt your data, and the data will always stay encrypted as part of the always encrypted offering. We'll look into how does the SQL Server transparent data encryption work in the SQL Server IaaS scenarios, and at the same time how it is encrypted, how it is integrated with the Azure Key Vault service as part of the extensible key management. So quickly going through the flow for the SQL Server Key Vault scenario. So what we are looking here is we are looking at a few steps. For example, let's say that you have SQL Server deployed inside Azure IaaS VM, and you want to turn on transparent data encryption, but at the same time you want to offload your keys as part of the EKM support. You want to offload your keys into Azure Key Vault. So we have built a SQL Server connector for that. Now there are a few steps you need to take. For example, given that Key Vault only supports the AED based authentication, you have to ensure that you are registering your SQL Server with the Azure Active Directory instance as the first step. You are creating a Key Vault and granting access to the SQL Server to the Key Vault, because the SQL Server is going to ultimately talk to the Key Vault. You are configuring now your SQL Server with the transparent data encryption. When you have configured that, then the keys will be offloaded from your SQL Server to the Key Vault. That guarantees you that separation between your SQL Server admin, and at the same time, in the event if something gets compromised on your SQL Server, then the data still stays protected because the keys to the kingdom are inside your Key Vault. So these are some of the steps which are involved in the flow when we are talking about SQL Server encryption. Can we go to... Now here we have a demo where we will show you how the connector works. So what we have here is you can download the connector from our download center. So this is your IaaS VM where your SQL Server is running. Now what you have done is you have downloaded the SQL Server connector on that VM. Now once that's done, then as part of some of the scripts, what I'm going to do is I'm going to show you. First I create a TD database. Now once I have done that, so the database is created. Now what I'm going to do is I'm going to set up the EKM, which means that I'm telling SQL Server that SQL Server, using this connector, I want you to talk to this Key Vault and offload the encryption keys to Key Vault. So that's where you are registering the this provider with Key Vault. So once that's done, then what you are doing is you are setting up some credentials, and these are the credentials we talked about. You need to provision access to the SQL Server to the Key Vault. So this is the this is the identity, and this is the basically the secret through which it will be connecting to key vault. So you do that, and as last step is you are turning on transparent data encryption on that database. So, and then you are telling SQL Server to use that identity and then offload those keys to the key vault. So this is where basically the database encryption is turned on. So it has turned on the database encryption. Now, what will happen here is, let's go quickly through. So this is my TD demo database. Then I quickly go over the properties, and I see here that TD is turned on. So I'll quickly show you here. So here it shows that encryption is enabled, and at the same time we have seen that not only the encryption is enabled, but because the EKM provider is registered, it's offloading those keys to the key vault. So that's basically the demo for. Can we go back to 7? So that's the demo for the SQL Server scenario. Now, coming back to our, so that was the demo for the SQL Server TD with key vault. We have talked about the key vault, so I'll skip those slides, and then at the same time we'll encourage you all to attend the key vault overview and detailed talk by Sumed tomorrow at 9 a.m. Now, coming back to this slide again and the scenarios. So what we have seen is we have looked at what are the different storage containers you could possibly have from a data perspective. You could have virtual machines for Windows, Linux, where your VSDs would be protected through the Azure disk encryption, or you could also have the option to use the partner volume encryption or the Cloud Link as the supported partner. For the SQL Server container, we talked about the transparent data encryption, the cell level encryption, the always encrypted. So at the storage level, you can protect your SQL Server content there. The Azure storage, we talked about the application level encryption, which is basically the recently announced storage client-side encryption, which allows you to encrypt your blob, tables, and queues with your key scheme. And then we talked briefly about the store simple, and then we covered the HD Insight and the Azure Backup Service. Now, with that, basically we have covered the data protection scheme across these different containers. We demoed, or we announced our Azure disk encryption offering. We looked into those details and the specific scenarios. So earlier there was a question about the Azure site recovery from this gentleman. Sorry, I didn't get his name. But from the Azure backup and from the Azure site recovery perspective, so site recovery does offer you the encryption options today. But from our perspective, what we are saying is the VSDs and the volumes or the disk will always be encrypted in your storage, or as long as you have the ability to or you have the access to those encrypted VSDs and you have access to those keys in your key vault, then the backup service, the recovery service will be able to either restore those VSDs or will be able to mount VSDs from that storage. Real quick, from the data retention and from the data destruction perspective, we always say that yes, your data is in the storage. The data is replicated, geo-replicated, depending on the location of your choice. But what happens when you are either leaving Azure, or for how long is your data retained? We are saying that the data is retained for 90 days. Now, you have the option as a customer to delete the data anytime. You have the option to delete the keys anytime, but with a caveat that once you have deleted the keys, then you will have to also think about, okay, then how do I, restore my encrypted content if I have a need to. So always think or always be careful when you are performing any kind of delete operation against, let's say, either encrypted content or the key vault content.
Are there any efforts on the roadmap to make that process more user-friendly, rather more self-service? Right now, if we want to recover something that was corrupted or whatever from one of our LRS copies, we actually have to go and get a ticket generated. It's kind of a big deal. It takes up to a week to restore.
Yeah, so I am not an expert in that area, but Josh, do you know the answer for that, or?
No,
Okay.
okay.
Yeah, so
Just
maybe
follow
we
up
can,
with us right after.
yeah, we
and
can
get you with the right
follow up
people.
on that, and then we'll try to get that information for you. So with that, I'm handing it to Thomas, and Thomas has roughly around 18 minutes.
All right, awesome. All right, so the only thing more difficult than going to a 5 o'clock meeting is being the second presenter in that 5 o'clock presentation. So I'm going to try to be really quick, really focused on some specific access control threats. My role is I work on the Azure Security Services team. It's a dual role. We do engineering work. We focus on features that we develop, but we also focus on securing the platform. So I'm in a very similar role as many of you are in terms of securing your businesses, and I want to share some of those insights, practical, as well as some of the features we have within Azure that you can use to address those threats. So Devendra talked about all of the encryption scenarios, which are great, but I want to emphasize that you're not done yet. Those address very specific concerns, and the fundamentals that you all know well on-premise still exist here. And I want to cover 3 specific threats and some related products and drill deep into those. So you've still got to mitigate the risk for compromised accounts. We're going to talk about multi-factor authentication, limiting excessive permissions, and adhering to least privilege practices. We're going to talk about Azure RBAC, as well as privileged identity management and the just-in-time access patterns that we've been working on in Azure for the last couple of years. You're right, you have to really press hard.
Yeah, you have to really press hard, yeah.
And then we're going to talk a little bit about detecting insider compromise or abuse of privileges via auditing, as well as anomaly detection and analysis. So let's quickly talk through compromised accounts. So as we all know, accounts with weak authentication methods, passwords can be compromised, and they're compromised every day. There's really effective spear phishing campaigns going on, but there's also a lot of mistakes, people writing the passwords down on stickies, and there's one right here, right? For Devendra's demo, the easiest thing to do, he's got a sticky with a password right there. It happens every day. So the idea is we really want to see multi-factor authentication across the board, and we really want to, from a Windows perspective, eradicate passwords altogether, and we're working on that. I'm sure you've heard about that in some of the other talks. So I want to talk a little bit about Azure MFA. So this can be used with Azure Active Directory or Windows Server Active Directory, and we'll go more into those flows in just a minute. But in basically, Azure MFA provides a second factor, phone call, or an application-based authorization. And then you can also look at securing your user accounts with smart cards, virtual smart cards, physical smart cards, which is really common among larger enterprises. So if you want to reuse your existing PKI, all the infrastructure you've already got today, you can do that. So let's go through this flow really quick, because I want to give you guys an overview of what this looks like for managing Azure. So I'll take you through the first flow. So as you know, all authentication for Azure management is done with Azure Active Directory. So in this case, the user will authenticate to Azure Active Directory, and if you've opted that account or that application into Azure MFA, the Azure Phone Authorization Service will engage that user's device, whether an application or a phone call, The second flow is where you integrate that tenant back to your on-prem ADFS infrastructure. And that authentication is actually sent back down to ADFS instances you control, leverages your existing PKI, your existing Windows-based login, physical smart cards, virtual smart cards. And like I said, both of these are available. We see a lot of larger enterprises that have investments in PKI adopting the option 2. But either way, the key thing is here, you really want to be looking at MFA in your applications. So let's shift gears a little bit and talk about limiting permissions. This is a huge challenge, I think, for all of us. Least privilege is something that we all want to follow. It's hard to follow. We're trying to make that easier in the platform. With Azure RBAC, now you've got 20 built-in roles. If you rewind a year ago, we had the administrator. It's a little hard to have role-based access control when you just have that one level. So now we've got Azure RBAC. We've got 20 built-in roles, as well as the ability to define custom roles. That's coming soon. So you have these general roles, readers, contributors, owners, and you also have these resource-specific roles, so virtual machines, SQL DB, all the different resource types. And one of the very important things is these can inherit, and I'll get to that in the next slide. Also, you can assign users, groups, and service principals, right? So service principals is really important. A lot of you probably develop applications, are probably operating in a model where you've got a very highly privileged account or certificate connecting to all of your backends. This will enable you to assign your application very specific permissions in addition to users and groups. And by the way, these are the same users and groups that you sync from your on-prem directory. So you use the same groups that you use every day. Just hit on Key Vault really quickly as well. There's very fine-grained access controls in Key Vault. So at the user or service principal level, you can get very hypersensitive on the permissions, and it really enables you to enforce segregation of duties. If you want to have one organization manage keys and have access to keys, but you want to enable development organization, for example, to build and develop the application, you can segregate those duties with these really fine-grained access controls. So a couple key points on access control, role-based access control we'll hit on real quick. One is you can assign at multiple levels, and this inheritance is really helpful. And so based on the way a lot of your teams probably work, you might have some central admins that are administrators on everything, but then you might have some departmental admins. And you can model that with RBAC in that your global admins can inherit those roles down the stack through resource groups and individual resources, but your departmental admins, for example, can have very specific permissions. It's proximity. That's what it is. So I'll give you a quick example. So say you've got a benefits app you're deploying. You build virtual machines, SQL DB, and storage accounts as part of that solution. And you've got a few different teams that interact with that. So you want to do some what we call role assignments, right? So you create a resource group, employee benefits app, you load them up with those assets, and then you go through and do these role assignments, which are available through the portal or through PowerShell or through REST APIs. And you can define and say the HR IT admins, for example, the same group you use on-prem, is the owner of this resource group. You can say the HR IT DevOps team, I want to enable to deploy the application, but not necessarily control access to the application. And you may want, for example, the HR benefits team to have read-only access so that they can monitor the performance of the app or just stay in touch with how the overall app development is coming along. So it can give you very fine-grained controls here. Now, if we shift into, this is the area that I focus on most and that probably keeps most of us up late at night, is these super user accounts. Almost every system has them, and they really deserve some special focus. One of the patterns that we've been working on in Microsoft for the last several years is what we call just-in-time access. And the model gives a lot of benefits. A lot of different types of attacks, compromised accounts or cross-site scripting, can be mitigated by not having any standing permissions across the environment. I don't know if this has ever happened to you, but this also prevents this mistake of like, I thought I was deleting the test tenant. This happens in every team that I know. An admin's logged in, they do a privileged operation, they do it against the wrong slice or the wrong tenant, and now that's gone. This happens every day. This has the side effect of helping with that, but it also enhances monitoring of admin activity. So we all deal with teams that say, I need admin because I need it. This helps you get quantitative data on how often elevations are being used and why they're being used. I'll go into some examples in just a minute. I want to stress this came from our learning. We use this internally to manage the platform. So, no standing access is a principle that we've been embracing for a long time in Azure. When you call in and you need support or you need, us to resolve an incident, engineers at Microsoft get very specifically scoped temporary elevations to specific assets that they need. So there isn't any kind of broad administration privileges going on. And now, you guys can now benefit from this learning with Azure AD Privileged Identity Management. So I want to walk you through some of those scenarios real quick. So, quick overview of AD PIM. You can look at all admin permissions in one view, set temporary authorization policies, collect justification and work item reference for every elevation, and we're working on support for Azure RBAC, so we're going to connect this in. So today the focus is going to be on your Azure AD management roles, and we're going to connect that to Azure RBAC. So what does this look like? So one of the things I definitely encourage you to do is go log into the portal, go to the marketplace, search for privileged identity management, and add this. It's in preview. You can try it out for free. And I think immediately you'll see value in even just this one screen, just showing you in your AD tenant who are your global admins, who are your security admins. I know for a tenant that I managed the other day, a development tenant, I went in and looked at it, and I found 2 accounts from a development project over a year ago that were still sitting there as security admins. It's very useful. But again, simple admin view. One of the things that's a little unique here is you see this active versus permanent, right? This is to start helping you have a high-level dashboard of how do I transition all these persistent access over to temporary authorizations. So just built in right out of the gate gives you overview and a dashboard for managing that. And then the tools to go in and set policies for activations. And this is when a user needs to come in and do some elevated work. They'll go in and activate that role. This policy will govern how long that authorization stays active, and at the end of that, that's automatically removed. So what does this look like? If I'm an administrator, it's a very simple process. I'm logged into the portal. I go to activate my role. I click Make Active. Based on the policy, I might have to put some information, some reason, some work item system, some work item IDs, and that's captured. And I'm in. And so that's a quick overview of PIM. We've got a whole bunch of references in the talks. There's deep dive talks later in the week. Definitely encourage you to go check that out. Let's cover auditing and logging very quickly. So we all know to detect any kind of compromise, we've got to have effective auditing. I'm just going to go really quickly through some of the standard auditing that is available and how you can use that. So you guys have probably seen this. This is standard management audit logs. So all management plane activities get logged here and are available to you. When you drill into those, the detail, I've obscured to protect the innocent here. You've got, who did it, what did they do, where did they do it from, and some other context that's really useful. Also, if you've got a SIM system and you just want to import all of these in, it's all obviously available through our REST APIs, and you can bulk import those in for analysis. Touching back on the privileged identity management, again, this is a dashboard that you can view elevations. So for those roles that you really care about, those most privileged roles, this gives you a very clear view of who elevated, why they elevated, how often they're elevated, and it supports that kind of overall permission management program in your organization. So in Brad's talk, in the keynote, you probably saw this. the Azure AD login anomaly detection. This is where we're processing billions and billions of authentications through our machine learning and looking to help, using our systems to help you keep your platform safe. So there's a bunch of different things in here. Brad talked about the impossible travel. My favorite's the potential brute force attempts. That's where you can go in and say, if somebody tries to log in 17 times unsuccessfully, on the 18th time they get it, right? I want to get an alert, because that really has that signature of a brute force or somebody that's guessing a password. So you can define a lot of these. You can get active notifications. I highly encourage you to check this out. I got asked yesterday, like, is this live? Yes, it's been live for a long time. Just, log into the portal, click on reports under your directory, and it's all there. So definitely check that out. Okay, and then I'm going to end on this. So if I could just get a quick raise of hands, how many of you can enumerate all the permissions in your whole environment?
Easy.
Yeah.
Everybody's an administrator.
Oh, yeah, that guy. Yeah.
Bingo.
No, I've seen that. Yeah, I've seen that one before. Yeah. No, that's a good one. This is a really, really hard problem. This is one of the things that I do in my job every day for the platform. And one of the things I think is most compelling, it's a different flavor of auditing. It's not the logging aspect, but when you look at auditing permissions with Azure Resource Manager and RBAC, this is now really, really easy to do at huge scale. And so I'll leave you with this. Get ARM access assignments, right? In one PowerShell commandlet, you have complete visibility by role, by user, by resource group, at the subscription level or at the VM level or at the region in one view. You've just shown all the permissions throughout your entire cloud tenant. So we think that's really powerful. We hope that'll work for you. And I'm going to pass this over.
Well, I'm sure you're also adding all the permissions within the VMs into that report, right? The local ones?
The local accounts?
VMs.
Oh, within Windows, yeah. Talk to me right after. I'll have some information on that for you too.
Thanks, Thomas. So in closing, what we need to do is we need to look at what we have covered in the last 60 plus minutes. So what are the different advanced technologies Azure offer you to protect your data, to safeguard your data, to help control your data and the keys, and what are the different access control options you have to to ensure that your applications functions correctly and completely. So we looked at, as part of the trusted cloud platform, we looked at some of the encryption offerings across the different storage containers. We looked at the encryption solutions and the broader supports we are adding to our encryption scheme. And at the same time, we looked at how you can control your encryption keys and the storage, and then allowing, securing, and managing, your admin accounts. Thomas demonstrated that. So that basically helps you understand what are the Azure platform capabilities as a trusted platform, what I can do versus what Azure does for me, and then what are the as part of the configurations, what configurations I can bring in to protect my data, safeguard my data, and then take it from there. So that's all about the Azure data protection capabilities we talked about. Now we have other related sessions. We did not cover, as we said in this talk, we did not cover some of the compliance controls or the security controls, the crypto related concepts, but there are other sessions including some of the SQL Server offerings. So there are a bunch of related sessions. We would definitely encourage you to attend those sessions. We have marked them. We did not include the time and the date, but yes, please look up and attend those sessions. And then tomorrow there is an introduction to Azure Key Vault, as I was saying earlier. There are a bunch of other learning references we have added, some of the security collateral for Azure and the Azure related applications. We encourage you to mark or track your, your sessions, so you can do that and then enroll yourself for some of the great prizes as part of the aka.ms/myazure challenge. And then, of course, we would definitely appreciate your feedback. Of course, we'll appreciate your questions as well, but the feedback around some of the scenarios we covered, which may not be completely, providing the encryption solutions versus the scenarios you want to cover versus the key management scheme you want to, bring in. So we would definitely like to hear from you. So please fill the evaluation and then let us know how we can get better, and at the same time, what are the scenarios, experiences, or the solutions we are missing. So that's all about the enabling data protection in Azure talk. Feel free to ask questions.
Bring the links page back. The links page.
Oh, the links page?
The deck is going to be posted online now,
yeah.
so you can download the deck directly.
Oh, thank you. What is that?
The deck will be posted to Channel 9 as well, so it'll be available on Channel 9, but it's definitely in Yammer now.
Yes. Sure, go ahead.
Is EKM available for SQL database?
We have folks from the SQL team, Wakim and Yakub. Do you want to answer that? Okay, sure. Yeah, the question is like, is EKM available for SQL database?
Given that we're at the end of the day, if you have questions, feel free to just come right up to the front and talk. Thanks, everyone.
Thank you.